we got a nice crowd where we could just talk to you all, and if you've got questions, I'll try to be loud too so you can hear me, but keep the headsets on, obviously. But if you have questions, just ask, because we're here to just help you on the things that we're working on. So, yeah, I'll do that. I get to drive? Okay. So my name is John Parello. I'm a principal engineer. I've worked at Cisco a long time. I've been doing all of our network management. I'm working now in a group called Outshift. With Cody, we came from our innovation labs, where we worked with a lot of customers on different problems, and everything now is AI, so we started doing a lot of work on that. So that's my background. I'm from New York originally, so if I get hyped up and start going quickly, just slow me down and say, hey, I got a question, okay? And then,
yeah, I'm Cody Hartsook. I'm a senior software engineer. Last 3 years, kind of been working in this AI, Gen AI space, so big practitioner. I've seen kind of the early transition from working with just LLMs in an application to now LLMs for documentation, RAG type situations, to now agents, and now agents communicating with agents. Yeah. That's kind of been my flow last three years.
Yeah. So what we're going to talk about today is typically in DevNet, you guys are all coming here saying, well, I'm going to work with Cisco's APIs and Cisco's SDKs and things to try to do the network management, to try to do configuration, faults, performance, security. What we're going to be talking to you about is Cody and I came to DevNet to help run DevNet itself. And we were tasked with the job of what can we do with less people and more AI? What can we do to help run DevNet, help run this show floor, help keep the business running? And while we were doing that, we were experimenting with AI so that we could see how we can run it as a business. So when you hear us talking about some things here, a lot of it is going to be about how to do a business function, but it's also going into network management, because the idea here is that once you start building systems with AI, you're going to want to make smaller and smaller self-contained AI agents to do a larger task. And whether you're doing network management, security, faults, performance, any of those things, you're going to want to make small agents that do a specific task and try to get them to interact, work as an ensemble. So we thought it would be cool to show you what we were doing to help run DevNet. Okay? So we'll show you how we did that and give you some things to take back home so that you can see how we've done it and try it out yourself. So, oh, it's not going to change from there. No, I got to change it from up there. All right. So first, all the logistics. Use your web app, sign up, and then do the ratings at the end. And if you have questions afterwards, you can go into the WebEx team space, and we'll answer them as best we can. But what we're going to be talking about is DevNet at a glance. I'll just tell you what we do to help you. How do we run DevNet? What are the things that we do? And it's 4 areas, so it's not too complicated. And we'll show you how that works, how DevNet works. And then we'll go over what is multi-agent software. What does it take to build a multi-agentic system? You could find an agent and say, that big giant agent is going to run everything for DevNet. But what we found is when you try to do any kind of a task, whether it be network management or a business application, it's better to do smaller encapsulated agents, just like we build software. Just like you have smaller contained classes and instances of classes, that's the same way agents work. If you flip agent in your head to proper object-oriented design, that's what you should be doing. Small, self-contained separations of concerns and stitching them together. Except these things are more interactive, more intelligent, and we have to try to make them work together. So we'll go over that. We'll give you a simple example of one agent working in Thousand Eyes, and we'll show you where you can use that code yourself to build your first agent if you haven't. Then we're going to go over all the agents that we built, some very complicated ones, some systems to help us build other systems, and then we'll show you what's next. What we have been doing is everything that we've been learning about building multi-agentic systems, we've been taking that and putting that into the open source. So Outshift at Cisco, where we are, it's the incubation arm of Cisco. What we've learned from building multi-agent systems, we're putting it slowly out into the open source so that the things that we've learned and the proper way to architect multi-agentic systems is out in the open for you to use. Okay? So, quick DevNet at a glance. this organization, DevNet, to help you all work with Cisco gear, really has 4 big areas. The first one is the documentation, right? When you guys want to look up the SDK and the documentation, we have to keep that up and running. We have to manage that. The different Cisco groups are taking their APIs and their SDKs and publishing it to us. We have to verify it and make sure it works before you guys get it. So all that has to happen. We have to verify the next releases. Is it backward compatible? We have to do all that work. Sample code. You guys all come in and you say, oh, how do I work with Meraki APIs? And you get samples. Well, we have to get that sample code. We have to generate it. And then now we're going to have to build AI agents that are samples for you all to use. So we have to maintain that as well. The labs. All of the labs that you have, the automated labs where you can come in and try things out and where we can test out gear, all of that has to be maintained and has a life cycle.
We'll show an agent later on that helps us do some of this provisioning, managing.
Yeah. And sandbox. All those sandboxes that you sign up for and that you grab, well, those things have to be maintained. They have to age out. We have to let people sign them in and sign them out. So it's the business of running DevNet. So again, for people who are just coming in, we're going to show you the agents that we built to help run the business of DevNet so that you can see how you can do that for anything, whether it be network management, faults, and performance. So Cody's going to go over the first one. And this is, well, actually, we're going to define an agent first. OK, how many people have built an agent? That's your part.
Yeah, anyone here built an agent? OK.
OK.
What framework did you use? LangGraph? Nice, OK. What about MCP? Anyone used MCP?
One MCP server,
cool.
OK.
Well, we're just going to start from kind of the basic here. So simple agent, we have an LLM, we have a reasoner, right? We've all kind of interacted with these, but we've seen the transition to now we want to make our reasoner be able to impact the environment, impact the world around it. So the first kind of incantation of that was tooling. So allowing it to essentially execute functions that can go off to an external system, you know, your APIs, your services, and actually make real change from its environment. So that's kind of a simple view on what an agent is. We'll probably throw in memory, probably be some workflows, but at its very core, that's what we're doing. Yeah, and then as that transitioned, we saw something like MCP, which is creating a standardized way in which we can call tools. So tools is very much a, implement it how you want it type of thing, whereas MCP is giving a standard interface for how the LLM can take context of what these tools provide and then call that.
Well, and in an MCP server too, think of it like if you want to connect to an external service, you want to connect to Salesforce to get data, you want to connect to your file system to get files from a division, then you can use an MCP server to host that so the agent has one place to go to get all that information, and you don't have to deal with different APIs. So instead of the agent building APIs to go to different data sources, everybody builds their data sources to the MCP server and then gets it in there. I like to call it like an FTP server. Like it's almost like, I want files, FTP it from different locations. It allows me to grab it in a unified way as opposed to copy from here and do that. It's a unified way of grabbing information so agents can get it easily.
Yeah, and then the transitioning to now even more of a general case where maybe it's not a service or an API that we have, but it's a black box that maybe is an entire another agent. So now we're having an agent using context from another agent and collaboration between the two. So this is kind of transition of where we've been heading.
And then one of the things that we found is when you are building these agent systems, and I think the gentleman over there said he did it in LangGraph, right? Think of LangGraph like a Java VM, right? You can go in and build a whole bunch of classes and they all run in that one VM, and you're in control of everything in that one VM. The second you're not in control, you're going outside of that VM, outside of that agent world of tools, you're going to have to go get data. But if you have two VMs that are doing different things, two sets of agents that are doing two different tasks, and you need them to communicate, and you're not in control of all of it, then you're going to need protocols in between to try to do the information exchange. That's where you're going to need MCP to get the tools, and that's where you're going to need A2A or an agent protocol to communicate between them. Now, how many people have heard of A2A? Okay, so A2A is a protocol, a definition of how to do a call to an agent and how to define an agent and get information back and forth between those. right? So that's the idea. If you're in control, just use one package, use LangChain or something like that to set up all the different agents. But once you're not in control, you need a remote way of doing that. Okay? Any questions? Yeah. Yeah, you can have multiple machines and doing it in LangGraph and have them going across, but it's over their protocol. It's like the AP protocol, right? If you're going to try to work on something, you did that one in LangChain, you did that one in Llama Index. Oh, that agent came from a third party. I don't know what it's written in. Now it's like, where are we going to get them from? So when you're in control of everything, sure. You could do it all together, do it all distributed. But once you start getting things like from different services, you're not going to know how to get it. Yeah. Okay. Thank you.
Yeah,
that's a good question. Thanks. Okay. All right. Good questions get chocolate. Okay. Next. All right. Multi-agent software. Again, this is what we're talking about. You have these different agents that could have been composed in different ways when they want to communicate to each other. A simple agent, one that has model and context, then they're going to have a protocol. So the blue lines are going to be that interoperating agent protocol. Okay. Once you have those agents set up, how are you going to make them talk? Well, you can make one monolithic agent, or you could have one supervisor agent that talks to a whole bunch of other ones, or they all cross-communicate, and we're all kind of networking people here. What does this look like? These are different ways to set up networks, spine and leaf, spoke, mesh. Well, that's what's going to happen. That same kind of protocol between the agents is going to have to happen at the upper level. So we don't know how people are going to be building their systems. Some people are going to do it very hierarchical. Some are going to do it custom. Some are going to have trees. Some are going to do one LLM brain and a whole bunch of tools. Others are going to be like, I don't know, they're all going to talk in a different flow. So Anthropic came up with these different models, and what we're trying to do is try different ones out based on the problem domain. So depending on what you're doing, if you have like a call flow that has to go through from one to another, you might map it out that way. Or you might set it up as trees of agents that you can talk to. It's got to be flexible enough to build the systems in a different way that you can. Okay? But that's how multi-agents work. You start building one, you get two to work together, then you're like, oh, well, I have three working together, I have an ensemble, I want to reuse them. Just like object-oriented programming, just like class reuses across VMs or within a VM, it's the same sort of metaphor. Okay?
All right, so now we're going to go through an example agent that we had. So at DevNet, we're looking at some network monitoring using ThousandEyes and looking how can we automate that, how can we retrieve what agents we have, what tests we have running, and do that all from natural language. So you could essentially have a WebEx room where you're talking to all of your ThousandEyes API and doing that all just through natural language. So I'm going to go briefly through the code. Anyone who's used LangGraph before is probably going to look familiar, but we'll just run through. We have this laid out. And we're going to use that first pattern that we saw, which was a simple agent. So we have an agent, and then we have tools. In order to build that agent, we said an agent is some type of reasoner, an LLM. So we're creating an LLM here. We have some utility functions that Cisco has developed to kind of provision different types of LLM connections. And then we're going to give it a list of tools here. So you can see the first one, get endpoint agents, get all tests, get test results, and then create servers. So these are the operations that we want to be able to provide to people. And again, we could have this in a WebEx bot. So anyone with access to this WebEx bot in their WebEx channel can create agents, get tests, whatnot. Now, our LLM, we're going to bind the tools. What does that mean? That means when we invoke this LLM with a prompt, we're also going to inject the signatures of the tools that we want to run. So let's say we have get endpoint agents. Are there any arguments to that function call? Maybe, maybe not. Get all tests, but create a HTTP server test, definitely going to be arguments to that. So in this call, bind tools, we're essentially going to give the LLM the structure of the arguments that it needs to pass in order to execute that function. Then we have this line here. This is kind of a utility that you get from LangGraph, but what is it doing? So now we're creating a way to take generated content from the LLM, where the LLM decides, I want to call this tool. The user asked, get tests for me. The LLM is going to say, I have a tool that I can get tests from, and it's going to basically create a text of what that function call is and what arguments it needs to pass in. Now this tool node is going to take that text representation and actually make a function call from that. So that is where we're going from the LLM to really an agentic operation that allows it to interact with an environment. And then in this section here, this is where we're talking about kind of what is the workflow, what is the flow of this agent. So we can make a single call to LLM, but this is kind of creating a tree or graph representation. That's where lang graph comes from. So we're adding different kind of node states that we want to pass through. This one is fairly simple. We have an agent node, we have a tools node, and we're just showcasing transitions from start to agent. And then we have kind of from that agent deciding, should we call tools or should we end this flow? And then we'll go from tools back to an agent and kind of loop through to make sure that we executed the prompt that the user wanted. So this is essentially the bare bones of how you would create a lang graph agent. All the tools are going to be defined here. These are essentially just function calls, nothing too crazy there. And now we're going to show a demo of this agent running, and we've run it with LangGraph Studio, which just provides a UI on top of it, but it's going to invoke this kind of top-level graph agent. So if I go over here, it shows me what is the layout of the graph. I'm then going to give it a prompt. I'm going to say, hey, do I have any ThousandEyes agents running? And we can see that graph flow is now being executed. The agent is saying, I have tools that I can use. It's going to execute those tools. Those tools are going to kind of push data into a state that we have. And then we can see everything laid out here. So we can see it got back my ThousandEyes endpoint agent details. So now we're going to say, do I have any tests running? Have any configured ThousandEyes tests? Again, it's going to go through this flow, but now it's going to execute a different function. Not the endpoint agent function, but the getTest function. So LangGraph Studio is a nice way to just be able to visualize the flow in real time. I think I have one last one where I'm actually now grabbing a test ID. Now I'm going to ask it, can you get test results for this specific test ID? And remember, I had mentioned in the tools, there's a signature for what arguments need to be passed. And get test results, one of the arguments is a test ID. So it's going to take that test ID out of the text and pass it into the function. And we get your typical jitter latency loss type of metrics. So this is a simple LangGraph agent. You could definitely make this more sophisticated with more and more tools for every kind of ThousandEyes API call you might want. And again, we could expose this through something like a WebEx bot.
Cool.
Authentication, yeah. It's a great question. So right now, we essentially have a ThousandEyes API key that we're using. And in a demo like this, we're just injecting the API key into the environment. Now, later on, we're going to show kind of more of a platform approach to building agents at scale. And that's where we'll probably handle authentication more in a systematic manner. This is more kind of a demo of how we would show things. And so we're just using an API key. But we'll definitely, that is something that we think about at more of the platform level as we scale to more and more agents.
Heads up.
Oh. Yeah.
Yeah.
Yeah. Yeah, so the only thing you really need to do, if we go back to the agent, yeah, so we're using, yeah. Yeah.
Yeah, repeat the question.
Yeah, so there's So the question is, if the API spec is changed, there's different endpoints that come in and come out, how does that impact the agent? How does that impact the LLM? So there's a couple ways that you can do it. Right now, we have functions that go off and kind of trigger executions from the API. So at that point, you would have to update maybe the function in order to have the latest. But you could have kind of a larger, more resilient approach where you use the OpenAPI specification to then generate functions to do that for you. So that would probably be an approach that you'd want to look into like in production, I would say. Yeah.
Yeah.
Uh-huh. Mm-hmm.
It seems like your approach, you have some did you tune your model?
Yeah, repeat the question.
No, there's no.
Yeah, so the question was, I do this, but every time I do it, I get non-deterministic results. So first thing is, that's why we say make them small, make them defined. If you think of your agents as, there's two ways of thinking this. An agent can be ChatGPT, it answers everything, right? But then the non-determinism is there. If you think of your LLM as just smart bundles of if statements and make it smaller and smaller tasks, then you're going to get a more deterministic result. So if I ask a question like, is this room crowded, right? And I keep that as one set of a yes/no answer, then you're going to get a deterministic result. But if you keep it wide open and your model's bigger and bigger, and I ask it, is it crowded? It's going to be like, I don't know. So divide these things up with proper software designs, and then the method invocations, try to make them smaller and smaller, and you'll get better results, more deterministic results.
In a practical sense, too, in LangGraph, there are things that you can do. So like system prompting is like a good one. So you can, every time the LLM is invoked, you provide some system prompt that gives it instructions, that gives it a clear idea of what it's doing. So that's one kind of easy approach. The other approach, you can see where we have this kind of graph flow that's defining kind of how the execution is going to flow. So oftentimes in a large graph, which we will show later on, what you might want to do is when you get to the end, you make an edge that goes to a reflection agent. And that agent says, given the initial prompt, have you sufficiently answered the question? Yes, give me a yes or no answer. And then you say, the LLM might say, no, you didn't really answer it that well, and make it go back to the beginning. Try again. So there's things like techniques like that in order to try to steer it into the right direction if you're not getting the result, first time for some reason.
Yeah. Okay, let's go on to the next one. Okay. So some of the things that we've done in order to help DevNet run is we built three major sets of applications. One is Jarvis. And Jarvis is open source. You can get that out from the CNCF. We've opened the entire platform up. So this entire platform is there. This is our SRE function. Basically, we set up an agent, groups of agents that can do our entire SRE flow. And we'll show you how that works. It's a massive one, right? But you guys can grab that one. Then we started realizing, well, it was before that even, we realized we were going to have to build these trees of agents that had small specific tasks. So we started building a platform where we could get agents and just attach data to it and then reuse these smaller agents. So we wanted reuse across the enterprise. If somebody had built an agent that interacted with Salesforce or interacted with Thousand Eyes, we're like, well, I just want to use that same one, but I just want to give it a different set of data. I don't want to have to go and build a whole new agent from scratch. So we wanted to make sure that we could build trees of agents that were reused across the company. So we built that. And then there's about 12 projects internally at DevNet for doing different things, for like setting up these courses, reviewing the courses, looking at the course grades, all these different agents that we're building to do these tasks, we're building there. And then there's the agents to do all of the Cisco stuff that you'll see, like setting up MCP service so we can do Ansible playbook. That's a whole other area where there's hundreds of things that are going on there. So there's a lot of things going on where we're trying to make agents do different work. So we'll walk you through Jarvis. We'll show you a bit about what we did with Cascade. These projects is for your information. And then the one that Cody showed you, the Thousand Eyes one, you can take that one back and you can use that one as a base and work with it.
Yeah, so we briefly mentioned Jarvis. Jarvis is a great tool that the SRE team has built, and I have contributed to some of the agents as well. And they were able to automate almost every SRE flow that we had. So provisioning infrastructure now can be done, checking JIRA tickets, generating code, all sorts of things can be done from this one kind of group of agents, ensemble of agents that you will see. And it's now being used internally, and I think has quite a high traffic as well. But you will see, to do something at that scale, the complexity grows. So what we saw previously was essentially this and this, with the interaction between these two. So now we have blown it up to this, where each of these sub-agents has its own supervisor pattern that we showed before, which is deciding what should I do given this input prompt? How do I send that down to my sub-agents? And all of this used to be in one large monolithic agent. And you would run that as a single Python process deployed to Kubernetes. And we got to a point where we wanted separate teams maybe that could be developing these things independently. So a microservice model now starts making sense. But in order to do that, even if these are all using LangGraph, we're not speaking in memory. We can't write to the same in-memory state. And so that's where the protocols come in. So initially, we started distributing these things into LangGraph remote graphs. And we had a massive remote graph agent. And now we're starting to look at, OK, let's use 808 as the interchange between these distributed agents. So now we have essentially the same UI, testing UI, LangGraph Studio, but you're going to see a much larger scale than we had before. So now this is the view where each of these represents an agent, and the paths represent kind of the flow of how things are going to work as the execution comes. So we're going to ask a question. Who is on SRE call? And then you get some JIRA ticket information. You can see one agent's going to be called. It's going to traverse down kind of that graph, making the network calls as it flows to a distributed agent. And that was a very simple task as well. Find someone who is on call right now. So as we look at this for, let's say, provision me an EC2 instance with this machine type and these ports open, you can imagine how the flow goes through that. But all of this has been automated and has really opened up, I think, the engineers in the SRE to be able to work on something like this and work on projects, as opposed to being, responding to requests from people about all sorts of tasks. Sorry about that.
Well, so you can imagine if you had done this as one monolithic service, the non-determinism is going to be like, whoa, what just happened, right? And how do you maintain it? So again, good software engineering practices, divide these agents, and what we're doing is we're trying to make sure that the protocols between them can work both in memory, out of memory, and you can build systems of smaller agents as opposed to one monolithic, where something like this would be untenable if you tried to do it all as one.
And to your question, it was really good in the last part. So what if something is indeterministic? In a system like this, you can't get around all of it, but there's so many moving pieces that you do need to have checks. So at every point, there is reflection. So after you make a task and it traverses down, it will go back and say, did I accomplish this correctly? Do I need any material or any user input? Do I need, an API key? Do I need more information from a user? Looping back. So all of those kind of mechanisms have been placed in this in order for it to actually work in production. We have engineered those guardrails in, you might say. Yeah.
Those reflections, the things that's checking is an agent that's checking on the other agents. So it's not a human doing it, it's an agent checking the other agent. Yeah. Yep. Okay.
All right.
15 minutes? Mm-hmm. Okay. Cascade. This was a way to try to build multi-agentic systems like that. We built Jarvis from scratch. We coded it up, and we were like, okay, if we're going to give this out to just say lines of business, to HR, to people that are non-technical, are we going to be able to do this in the same way? So building an SRE is like, well, we're doing it for ourselves, and it's all in the geek domain, right? But when we start doing this to sales and things, and we want to push it out, the data becomes more important than the coding, and we want to make sure that it's easy for people to do that. live demo for Cascade. Oops, yeah, go to that one.
Slide
You're the live demo guy.
There we go.
Yeah, all right. So we'll play through here. So what we did with Cascade is we set up a directory of agents. And go ahead, Cody, you can talk about those. These are the running agents on the bottom. These are agents that are stood up as a service. So a ThousandEyes agents that is bound to an instance of ThousandEyes. Up here, these are agents that are not bound yet, that could be bound to data, but it's an example agent that somebody can fork and say, oh, I'll bind that to the instance, I'll put in my keys, and then I'll deploy it. So this could be like ThousandEyes agents for New York, ThousandEyes agents for London, like that. And we build that with different different agents that we could reuse. And the idea was that people would donate them back in, and we could start to use them. And then you can go to the top level one where you could just say, hey, I'm going to fork off the code and do it from scratch, right? Okay.
All right, so in this section, we're going to look at only agents that are running. So a part of this platform built an SDK that when you build agents with our SDK, we can manage and monitor what agents are running, what is the state of those agents, and we're able to with API-driven requests prompt them. So in this case, we're going to pull a running agent that we've discovered into our kind of canvas view, and we're able to send a prompt to that agent directly from this view. So this can be running essentially anywhere. It's backed by NAT's PubSub system, so all the agents can be running on-prem in the cloud as long as they can reach our one NAT's PubSub broker. You can see in this case, we sent a message to this. Can you get some information about Cisco buildings? I was able to retrieve that. And then we also asked, can you graph that data that was retrieved back? So we're handling multimodal data as well.
So that multimodal gets a little rough, where like some agents you say, I want to return an image, I want to return a stream. So we kind of encapsulate it in there and say, hey, you get the agent, we'll handle all the tool calling and also the inputs and outputs so we can stream or bring it in. So then, yeah keep going.
And then this network monitoring is that ThousandEyes agents that you saw. And this we're showing it in a different view. So now it is just one agent in that catalog of agents that we have uploaded. And now we're kind of prompting, and you're seeing essentially the same data that you saw before. So now in this next step, this is a kind of a powerful feature that we wanted to have, being able to dynamically compose agents into an ensemble. So what we're going to show here is we're going to have a top-level agent. And now we wanted to be able to communicate with these agents, but we haven't defined in code who we want it to talk to. So in LangGraph before, LangGraph you have to statically define in the code what are the agents, what are the tools I want to talk to. In this platform, we're actually going to send an API request to Stanley Morgan, and we're going to say, can you register these tools as something you can execute and be able to dynamically configure downstream agents as collaborators?
Yeah. So this gives you a more dynamic one, and the example that we did here is like Stanley Morgan. It's like a company that has, you want to look what's in the buildings, you want to see what their network monitoring is, you might want to see the financial data, the ticker data, and then we have a chart pattern analyzer that can analyze the data. This is one function for a group. So like if we're doing DevNet, we're going to have one that does API docs, one that does the courses, one that does, so each one of these things is doing a business function. We can stitch them together and run a piece of the business. And you can see in here, these agents were already built and we're putting them together. You might have had one from another department. I just want to put them together as a different flow or a different set of work. You can put them together this way and then deploy them, right? So the intercommunication between these agents is what we worked on. And we're taking that out into the open source, and we'll talk about that in a bit.
So when he clicks that, essentially we fired an API request to this one, and it dynamically configured tools to be able to communicate with all of them. So now as we send a message to this top level one, get financial data, in the same as like the ThousandEyes data we showed before, it's going to realize it has a tool. In this case, it's distributed out to this financial data, and it's going to retrieve that. So with no static configuration within this beforehand about how to retrieve financial data, we're able to fully API-driven connect these things. Again, we're going to ask a question about chart pattern analysis. It's going to hit this agent, again, showcasing some of the multimodal work that we did.
And then once you do this, again, it's a good point about the non-determinism. You want to be able to trace and see what happened. So inside the agent, there's OpenTelemetry, the OpenTelemetry for the LLM. But then all these calls that we've done over the network, right, have to be traced as well, and they all have to be linked back. So all of this is instrumented with the OpenTelemetry, so you can see them in here that we've got the whole call path and trace down through the different agents. And it gets complicated because one agent could call another agent that can call a model that's somewhere else. We've got to link all that together. This is the vision that we see for building multi-agentic systems as we went through this. So while we did this at DevNet, we think people should be building agents this way, and then not just in one system, but connecting them. We're Cisco. We're going to see them as networked systems, and then we're putting all this in the open source so that you can do it this way as well. We're going to standardize this way of doing it. So, okay, so you get all the OpenTelemetry from there. And then what we did, one second. What we did is we took this agent, these agents, and we put them into a WebEx team space. So you could put them in a Slack channel or a team space, and it's immediately deployed. So we don't have to worry about like, oh, we'll have to build an application for it. Well, just put them in the Slack channels. Yeah, good.
You mentioned about OpenTelemetry. You saw the metric. Do you have, sorry, the tracing? Do you have any way to know if it is hallucinating? The AGR hallucinating, so the data that it was small is not expected. I know it's not observable.
Yeah, that's a great question, and is definitely a problem that people are looking at and we're trying to tackle. I think John kind of mentioned earlier, one way to kind of try to minimize hallucination is create a very domain-specific task that you can tell if hallucination happened or not. If it's a very general task, if a monolithic agent, it's very hard to tell if it kind of made things up or not. But if it's specific, then it's a little easier. Then there's also kind of the task that we were talking about, where maybe you try to have another LLM that's a grader that can grade the response and say, hey, was there hallucination here? If there was, loop back and try again. So there are things like that that we can do. And then there's also some evaluation platforms that are coming out. So LangGraph has an evaluation platform. Some of the open source things that we'll talk about maybe later, we were also thinking about some eval. And observability is an important piece of that as well. If you know that your agent needs to talk to an external service, if there's no API call, that's a great indication that there is hallucination.
Yeah, there's a growing work on this to say, like, how do you reduce the hallucination? Some people are like, well, it'll get better over time, right? But think about when you're talking to a person, you're talking to anybody. If you have a direct lawyer line of questions, yes or no answers, please, because you're trying to get to the root of the problem, right? But if you ask somebody like a question that's not on their topic and they want to, they're going to be like, yeah, I think I got it. Like, that's what people do, right? The LLMs are kind of doing the same thing. If you keep the line of questioning direct, you'll get direct answers. If you ask wide questions, you may or may not get it. It depends on which agent was trained on it. So the trend right now, I think one way that I would do it is keep the LLM small and expert on a topic, and keep the line of questioning direct. If you want a deterministic system to put out and have to do a deterministic task, you may want that hallucination and that for some of the things that you want to do. It depends what you're trying to do, right? So it gets interesting, but we think that networking these things together and making them communicate together as an ensemble is the way to do it. Experts on things. And one thing going out to the future is, I ask you a question and you don't have the answer to it, you may go find an agent that does that and bring them into the conversation and find somebody who does that. That's the next level up. And that's the kind of stuff that we're going into the next section. So what's next is we're taking all of these things that we're talking about and trying to put them into the open source. There's a lot of issues. We're trying to make production grade systems, non-joke systems that are using LLMs for production. So the vision of this is that we want to make an open, interoperable Internet of Agents. You might have heard it. It's 1999, 2000. People are running web servers. Cisco's role, the communication between it. I care more about the S on the end of HTTP than I do which web server you're using or which LLM you're using. I care more about the protocol between it. So that's the mission that we've got. And there's different areas that we're trying to work on the problems of stitching these agents together and making a coherent system out of it. You can see we grabbed that Thousand Eyes agent, but that Thousand Eyes agent had better have an identity. It better have a certificate that's signed that I know that that's the agent I'm allowed to run. That agent description should be in a catalog of agents. Can I do Thousand Eyes? Can I do SRE? Can I do HR? Which ones can do that? I want the Thousand Eyes agent, but I want the instance that is running against New York or the instance that's running against Kuala Lumpur. the semantic and the transport. We're trying to say that when you communicate over A2A or MCP, great. But you know what? Please, by God, separate out the transport protocol. Don't make it HTTP 1. It's not going to work for us to scale systems out there. We need pub sub. We need multi-agent communication. I need to say, who can supply me something? And somebody say, I can, and then I talk to you.
Streaming, bidirectional streaming.
Bidirectional streaming, and I want to get updates on things. Workflow. Some of these systems must pass through gates. You said yes. You said ship it. The human checked it and signed off on it. The next person said, okay, deliver it. It must go through certain flows. You're going to need something to track that. And I might have context to pass. We talked about and showed observability. We're going to have to see what happened. You can ask real time, did it hallucinate? But I might want to audit it later and go, what the hell happened? You know, what happened on this call? Can I check and see? And I might have an agent that's looking at the logs going through, hey, that doesn't look right. I'm going to go back and check it. Right? So you don't have to check everything in real time. You can go and check the audit as well and say something was bad. And then security. All the way through, it's got to be secure. You need identity. You need directories for that. But you also need role-based access. If I ask you a question, then you're going to have to be, like if I want to say, is this room full? I could say yes or no. But if I could say who's in the room, I may not be authorized to ask that. So it depends on of who I'm asking. Is the agent allowed to see more information than it's allowed to report on? These are complicated tasks that we have to work on, and we're trying to put them in the open source, conquer those, and put them back out. What we've shown here is just the beginning of it. It's going to get a lot more complicated, and we're working on it.
And we have a collective of 20-plus companies that we're working with, from startups to large companies, try to come together and decide what are the specifications for all of these different kind of working group components.
Okay, so the take-home is the Thousand Eyes agent, right? So you guys can take that one and try to build a simple agent, but then take a look at agency and see what you can do with the SDK that we're releasing. We're also putting out a reference application in agency. The reference application is going to be a coffee conglomerate, because we thought like having farms that could deliver coffee and coming and going and doing supply chain might be fun. So take a look at the Thousand Eyes agent, but also take a look at the reference application we're putting out. It will get more complicated and more sophisticated as we get more sophisticated in those components. So the Thousand Eyes one's there. You can take a look at the course material. I have the QR code to get it, but that's the GitHub repo.
As a challenge, too, if anyone wants to create a pull request to take some of the tools that we had and add an MCP server as a tool instead of just the kind of more traditional tool. So see if anyone wants that. What's that? On this project, yeah.
Yeah, go for it. And then agency is there. That's the GitHub repo for it. It's agency.org. If you want to join in, you want to participate in the open source movement, then you can come and join in there. That's where we're going to be talking about all these different topics. We have a lot of user groups from AWS, Salesforce, Dell, Cisco, all the Okta. And then the companies that are contributing are LangChain, Llama Index, Glean, Galileo, all these other companies. You can check them out on the webpage there. Okay. All right. We have some videos up there. We're going to be posting some more YouTube videos as we go through. We just released a whole bunch of code. So in the open source, we're going to be putting out some videos and how-tos on there. And yeah, so as a recap, we showed you DevNet, what multi-agent software is, and we think you should be building multi-agents, not one big conglomerate. The simple agent you could take home. You got an idea of some of the larger scale ones that we've been working on and how we've been going through it. You can see what's next with agency. Take home the GitHub repos, and then complete your session surveys and all that stuff so we can keep coming back and keep talking to you all. Okay?
Thank you, everyone.
Thank you very much.
Thanks for coming.
Thank you.